Going on, guys? This is Matthew Poyle at Eastern Kentucky University. This is video assignment number 3. We're going over hydrogen NMR, carbon NMR, and mass spectrometry. My compound is modafinil, proceeding from video assignment number 2. So I'm going to continue it with this content as well. So we're going to hop right into this. All right. I want to start with the figure here: 2 aromatic rings, an alkyl halide group, and an amide group. These aromatic rings right here, these hydrogens resonate between 7 and 9 ppm. This alkyl halide, or the alkyl halide hydrogens at position 16 and 7 can be predicted to be lower than 6 ppm due to their location on the figure. The number of hydrogens each peak represents is in red underneath each. These are integral values on this graph right here. So we can see exactly what we have in the sample from these peaks. We have 10 hydrogens in the peaks, ranging from 7.35 to 7.51 ppm, corresponding to the number of H's in the aromatic rings here. So we have 2 broader peaks at 7.07, which is right here, and about 5.62, which is there. These represent our nitrogen bonded hydrogens, which are up here in 19. From splitting, we can see that the singlet, which hints no adjacent hydrogens, at 5.2, which is here, this singlet has no adjacent hydrogens, and the 2 doublet peaks, meaning one nearby hydrogen, between 3 and 3.5 ppms, which would be right here. Those are the 2 H's from position 16. So right here, this carbon has 2 hydrogens splitting off, and that's what's showing us because we have 2 adjacent hydrogens. So as we continue this, we're going to move to our mass spectrum here. And all right, so here's our mass spectrum, ranging from 0 to about 250 and relative intensity to 100%. So our mass spectrum for modafinil, it's showing us here at 161 that this is the base peak. So this is what we interpret as the base peak, the most abundant ion in this solution. So this is labeled as M, and then M plus 1, this peak can be seen right here, is around 17.89%, and the M plus 2 abundance is approximately 4.89%. So as these radicals separate out of this compound, the peaks are expected to be seen on this graph. All right, so now we're going to move to our carbon-13 NMR. So I want us to look here at modafinil for a minute. We see that we have 2 aromatic rings on the right, and we have a C double bonded O next to that nitrogen and between the nitrogen and the sulfur. So these are what are going to show up on the carbon-13 NMR. These are the only 2 signals that we're going to have. So as we look at our graph, we're going to start from left to right. These aromatic rings here are going to be seen here between 190 and 200 ppm, and the other signal, the C double bonded O, is going to be a little bit less. It's going to be between 150 and 125, and this just tells us how many carbon environments there are in the compound. Like I said, there's only the aromatic rings here, which have these hydrogens coming off, and this C, and then the carbon here. Everything else is oxygen, oxygen, sulfur, and nitrogen. So in conclusion, this is our hydrogen NMR, carbon NMR, and mass spectrometry for modafinil. If you guys have any questions, please be sure to let me know. Thank you, guys.